Hello, welcome back to the lecture series on network layer protocols of the internet model. In this video, we are going to learn about unicast routing algorithms. The agenda is we will learn about the concept of unicast routing, then unicast routing algorithms. After that, the meaning of optimization, and then intra as well as inter-domain routing concept. So what is the concept of unicast routing? We know unicast means there is one sender and one receiver. This is also known as P2P communication or peer-to-peer communication. So for unicast routing, proper routing algorithms are necessary so that packets may be transferred from the sender to the receiver. Now, the routing table consists of two different types of routing. One is known as the static routing and the other one is known as the dynamic routing. The static routing is manual in nature, whereas dynamic routing is automatic. Now, what is the meaning of this? Manual nature of the routing table means the routing table updates about the internet configuration is done manually. Even if there is a single change in the internet, that should be updated manually. Whereas in dynamic routing, every update is done automatically and on demand basis. Today's internet calls for dynamic routing and hence we require dynamic routing algorithms. Now, why do we need routing protocols? We know the functionality of a router are three in number. Number one is the delivery. Number two is forwarding. And number three is routing. Delivery means how the packets are handled by the underlying physical network under the supervision of the network layer. Forwarding means how the packets are actually delivered to the receiver from the sender. And routing helps in the forwarding process by creating a routing table that actually maintains the path through which the packet must move in an easy manner, in an optimum manner, so as to reach the destination. Now, what is a routing protocol? A routing protocol mainly is consisting of rules and regulations that must be followed by a particular routing algorithm so that packets may be delivered to the destination from the sender in an efficient manner. If there is a change in the internet configuration, that must be updated in the routing table and hence the forwarding is done. So this is a routing protocol. Now, what is optimization? We need an optimum path. Suppose we consider this network having some nodes and end stations. Suppose this is end station A and this is end station B, and in between we have several intermediate nodes through which the router must send packets. Optimum path means suppose A wants to send 2 packets to B. So which path should it take? Should it take this path and then here and then this one? Or it should take this path, then this path and then this path? Or still this path, then this one, then like this it can go here. So there are many paths through which the packets may be sent from the sender to the receiver. Now, what is the optimum path? This optimum path basically means what is the best possible path, and that depends upon several metrics. Now, what are those metrics? The metrics may be the cost. What is the cost of sending these packets through this path? If this is path 1, having a cost say X, and this is path 2, having a cost Y, if X is less than Y, then definitely this path X is the optimum path as per the metric of cost. Then another metric is hop count. Hop count means how many nodes are there in between the two end stations or the two hosts. We call it host A and host B. For this case, we can see that there are basically, see, this node is already connected to the host A and this node is already connected to host B. In between, we have two nodes here. Similarly, for path Y, we can see that there are 1, 2, 3 nodes. So definitely for the hop count case, path Y will be larger than path X. So best possible path should be from path X, and this will be the optimum path as per the hop count. So we should take into account the minimum hop count in a path. Then the metric comes, which is a policy. What is a policy that must be adopted while going through the path? That policy can be in terms of throughput or in terms of delay. Now, if we consider a satellite link versus fiber optic link, then definitely the satellite link has a higher throughput as compared to the fiber optic link. And if we consider the delay metric, then the fiber optic link is faster as compared to satellite link. So that way we have to make a trade-off, keeping in mind all these metrics so that we get an optimum path. There are many cases where delay can be tolerated, but cost cannot be more. So in that case, we can adjust accordingly to make a trade-off. So as per the following parameters. Now let us consider this network. There are 4 networks, network 1, 2, 3 and 4. In between we have a router. Now as per the optimum path, we have a network 1 which wants to send 3 packets, we can see, to either network 2, network 3 or network 4 through the router. Now the decision has to be taken by the router as per the metric of either cost or hop count, or the policy based on throughput or delay as to which way to route the packets from network 1. Let us now turn our attention to intra-domain as well as inter-domain routing. For that, we need to understand the concept of autonomous system. So let us consider this figure. We have 4 different autonomous systems: AS1, AS2, AS3 and AS4. Now what is an autonomous system? An autonomous system is a system which consists of several nodes, routers and intermediate nodes, which itself can form a network. And if any packet moves within that autonomous system, then it is called intra-domain routing. And if the packet moves from one autonomous system to the other autonomous system, like if the packet moves from AS1 to AS2, then it is known as inter-domain. And if it moves within the system, then it is known as intra-domain routing. Here we can see that there is a router here and there is another router here which forms a pathway to the next autonomous system. Now if this host H1 wants to send any packet to, let's say, this host H2, then it has to route the packet through this router and then it comes to the next autonomous system and then to host H2. So this way it becomes an inter-domain routing. Now let's turn our attention to intra as well as inter-domain routing. We can see here routing protocols can be intra-domain as well as can be inter-domain. In intra-domain we have two different types of routing protocols. One is based on the distance vector routing and the other one is based on the link state routing. In distance vector routing, there is RIP, a routing information protocol. In link state routing, we have OSPF, and OSPF stands for Open Shortest Path First. For interdomain routing, we have the concept of path vector routing. Here, the protocol that is used is BGP or Border Gateway Protocol. To summarize, in this video, we have learned about the concept of unicast routing algorithms. Then the meaning of optimization, we have learned about the various parameters or metrics by which we can create an optimum path. Some of these are cost or the hop count or the delay and the throughput. And we have learned about the overview of interdomain routing as well as interdomain routing. Then the routing protocols based on interdomain routing and interdomain routing were also discussed, like RIP and OSPF for intradomain and BGP for interdomain routing. Thank you.